Right, it's almost time to fire up this baby. I've had the power supply out. I've still got to check out those two capacitors, and there's two others I've got to put back on, but yeah, they're all okay. I want to connect it to this dummy load contraption, and to do that I have to make a cable with these pins that connects from there into that socket, the power socket, so I can put a load on it, and then if it's all looking good I can connect it to the backplane of the computer. I haven't got the cards in there yet, but I thought, well, what I can do now is at least plug in the power and hear the fans spin. And after a few minutes of panic I thought I'd lost the key, but I found it again. And if I plug it in and turn the key, nothing happens because it needs this to be plugged in, which goes to a thermal switch, obviously normally closed thermal switch, that if it gets too hot, if this gets too hot, that will open and cut the AC power. So I'll put this around the back, just plug that part in. I won't put this in, won't put the power into it, and then I can turn on the key and we should be able to hear the fans go. There's the back of it. This is just plugged into there. Bit of extra light just so we can see. You've seen it, good, don't need that anymore. And now we can turn on the key. Those two fans are both blowing out, and there's one inside the power supply box which is blowing into the box. This one at the back here is blowing into the power supply box, so all the air runs that way. Well, that was interesting, wasn't it? So now to make up the cable for the dummy load, put the capacitor back on the power supply and test it. Right, I'm just using my prototype low ohms adapter to measure the resistances of all these. Currently looking at this one, which should be 2.8 ohms, and you see 2.824. This bottom meter is just measuring the 1 volt across a 10 ohm calibration resistor in there. So I know that it's working properly. 100 milliamps through 10 ohms should produce 1 volt, and that's very, very close to 1 volt. So I've just got to do the rest. This, I did a video on that a while ago. This is the new improved final version, hopefully, to go in a jiffy box, but it's not ready yet. But so I'm using this. Of course I haven't got the oil in there yet, otherwise it would leak out. Once I've checked all these and got exact values, which is all a bit higher than calculated because of wiring, but then I can make up a harness for the PDP-8F and test his power supply. Now I'll continue testing this. Right, we're almost ready to power up. I've put the capacitors back on, put the little straps, these little straps that connect the capacitors together, made up the cable to the dummy load. Haven't yet loaded up the oil into the resistor tubes. I noticed on the plug coming out of the PDP-8F there's this little loop between two of the pins, and I wondered if that was some sort of a enable signal that had to be set in order for the power supply to work. So, you know, would I need to put that on here as well? But looking at the schematics, the engineering drawings for this thing, it appears to just change the behaviour of another signal that goes into the computer, but doesn't control the power supply operation, so I don't think I need it. Now, this is the pretty simple power supply of all of them. These two only got 3 voltages, the others have more voltages. There's the ground, 5 volts, minus 15, another ground, and plus 15 volts. Now, when I was looking in the engineering drawings for that thing about that wire, I saw that this fuse, which is the tiny fuses over here, you can barely see them, there's two tiny fuses, they were only 15 amps, yet this is 20 amps just here, another 7 amps for that. That's on a different fuse anyway, but the 1 amp for the plus 15 volts and 20 amps for the plus 5 both run off the same fuse, which is only 15 amps. So how can that be? And I found a note in the diagrams that said, yeah, this is 20 amps, provided that minus 15, that doesn't make any sense. Oh yeah, maybe it does, transformer load. Yeah, this is plus 5 volts is 20 amps unless you're drawing more than 5 amps out of the minus 15. If you're drawing the full 7 amps that that's capable of, then this is only good for 15. So that's something to watch. The load capabilities of individual power supplies may be contingent on the currents being drawn from the others. So what I'll do is just disconnect that, which will make the minus 15 draw only 5 amps, and then we can draw the full 20 out of that. And then on the back we have the banana connector going to the oscilloscope. I won't bother with a meter to measure the voltages, I'll just use the oscilloscope, that's accurate enough, and we can see any ripple as well. So I think I just have to load up the oil and turn it on. I'm also going to, just for safety, run it through variac, wind up the voltage a little bit slowly, just in case there's some nasties going on. I'll only get a small explosion instead of a large one. Put in the oil. This is the original oil that was in this one. And pour the other one. Baby oil. Takes 17 babies to make that much oil. I would have thought you wouldn't need so many. I'll screw the lids on later. Alright, I've chickened out. I didn't like the idea of the 5 volts, 20 amps being drawn through these little pico fuses, which are only 15 amp. The one that supplies the 5 volts is only 15 amps. So yeah, I don't want to risk it because they're soldered in and I don't have any replacements. So what I've decided to do is disconnect that from this terminal and connect it to these 4 resistors instead, which will cause only 13 amps to flow. I'll still keep that running at the full 7 amps on the minus 15 because that's the core memory, and we've got core memory, so I don't know how much more core you can put in there to need the full current, but that's on a separate fuse, so that should be alright. And because it hasn't got a full complement of boards, it won't need the full 20 amps of plus 5 volts anyway. 13 amps should be heaps. It's more realistic to test it that way, I think. I'm just using that one of the mounting screws there as placeholder for this extra connection. So let's try it. And with that rewiring, I have to use a different terminal rather than the 5 volt terminal to measure it. So we'll do that. Try that first. I believe the power supply can work down to about 140 volts, so I'll start the variac off there. Start at 150 volts, and now I'll turn on the key. And a bit slow to start. You got anything here? Got some ripple, but only in millivolts. What's going on? Let's give it some more volts, since nothing's blown up yet. That's 200 volts. Why we got Only a bit of ripple there without any actual voltage. I'll try and work out what's happening with that crow in a minute, but let's look at just with this meter. 5 volts, 4.8, minus 15, minus nearly 15, plus 15, plus 15. Okay, now that's still at 200 volts mains input, so we'll wind it up to 230 or 240. It's 230, 240. So no change in the 5 volts. 15 volts is the same. Plus 15 is the same. So yeah, it looks like it can run down. Let's just see how low it can go. That's 240 volts. We'll see where that starts to drop. It's still within spec for TTL, 4.75 volts at 160 volts input. That's 140. That's still just within spec for TTL. That's 120 volts going in. 4.75 plus 5 volts, minus 15, minus 13.5. That's probably still workable. And plus 15. Yeah, that's with 120 volts, so it works pretty low. Taking it back up. Take it to 250, which is more typical of the voltage around here. 15 volts on the plus 15, minus 15. Good enough. Plus 5. It is a smidge low. I wonder if that's the load or if I need to adjust the voltage in that thing. I think I'll turn it off and disconnect the load and see what we get with no load. And we're getting some warm baby oil. Actually getting fairly hot, very hot at the top on this one. Right, that's with the 5 volts disconnected. Power back on. 4.93. It just doesn't like that load. 13 amps. No sparking. You think you get some sparking at 13 amps. I think once it's in, I might adjust the 5 volts to come up a little bit. Once I've got all the boards in. What's going on with the oscilloscope? I want to see the ripple. Alright, there's ground. 1 volt per division, so 1, 2, 3, 4, 5. It's a little bit low, a little bit of ripple. Let's switch to AC coupling. And 200 millivolts per division. 130 millivolts ripple. Yeah, not sure what's a good value for that. Right, it's the next day. The troubles I was having with the digital oscilloscope, I blamed on it being a digital oscilloscope, and I thought, well, I'll use this analog one to try and look at the voltages and ripples. Of course, it was just me being an idiot, couldn't use the oscilloscope properly. So I turned it on via the variac, and I started at 150 volts again, which I now know is bad. And it started making some horrible noises. The fans wouldn't start. There was a buzzing sound coming out of either the transformer down there or the variac up here, not sure which. And then this circuit breaker popped. Let it cool down, put it back in, tried it again, popped. Wound the voltage up to normal, and then there was smoke and a flash down here, which I now know was this fuse going on the minus 5 volt side, on the minus 15 volt side, and the smoke was, and you can still smell it now, don't know if you'll be able to see this, but there's a track from the AC connector there, charred, burnt out rather, and the PCB's charred, and there's a smell of burnt PCB. That track goes from the one side of the AC to one side of the bridge rectifier down here, over to that. For a while there I wasn't sure what was going on, and then I went went and looked at the footage I did last night and edited it, and then it dawned on me, this being a regulator will produce its rated output even if the incoming voltage is low, which it was with the variac, at least, you know, within a certain amount, depending on how much headroom the supply's got. And being a switching supply, it can produce the required output even with quite a low input voltage. And I was running it, you know, damn near half the normal input voltage, yet pulling out the normal load from this into this dummy load, pulling out the normal currents and voltages, which therefore meant that I was inputting about twice the normal current from the AC side, which is why the breaker popped and probably why this trace burnt out. And I'm also worried that I may have burnt out the half of the bridge rectifier, which might have led to this trace here burning out. Maybe excess current through the rectifier shorted out a couple of diodes and then blew this trace. So I'll take off these caps and check the bridge rectifier and repair the broken trace and put in a new fuse and start it up again without a load and without a variac, and just see if the voltages come back. The +5 and the +15 are still good, it's just the -15's gone. Yeah, so that's a worry. I probably won't get around to sticking cards in this box in this video because it'll be too long. So I'll return once I've investigated the faults in this a bit more. I've removed the caps and the straps that go along here to the terminals and the clip that holds it down, and you can see there I hope you can see the burnt out trace goes from one side of the AC input to one side of the bridge rectifier. These other 4 dark marks are just glue from the rubber that spaces the capacitors up a little bit. So I tested the bridge rectifier in there, and yeah, it's failed. Here it is, and we can demonstrate that fairly graphically. I'll look at a good one with this little multifunction tester contraption. The 3 terminals 1, 2 and 3 are red, green, blue. So if I put the red and the blue, the 1 and 3, on the AC inputs to the bridge rectifier, and then connect the middle one, the green, pin 2, to the positive output of the rectifier and tween it on, we should see the cathodes of the 2 diodes joining to the middle pin. There we go, 2 cathodes joining to the middle pin. And if we move the middle pin across to the negative output of the rectifier, we should see the 2 anodes joining to the middle pin. There we go. So that's what a good one looks like. Now, for this one that came out of the power supply, red and blue to the AC, green to the plus, and 2 cathodes going to the centre again. I hope that's visible, I assume it is. And if we go to the other side, the negative, with the centre terminal, test again, not 2 diodes, we get 2 resistors, and they're not even from one side to the other, so 2 of those diodes have turned into resistors or something, and yeah, basically this thing's wallaby. Now, I haven't got any like this, and I don't want to try and adapt something like that. I probably could put that there and run wires, and they have to go around this side. There's not enough room when it's in the case to go on this side, around here to the terminals. But you can still get this sort. I get a 50 amp one instead of this is 35 amp. Get a 50 amp one, and from DigiKey, that'll take a few days, and replace it properly. And also the Pico fuse that vaporised. In the meantime, what I can do is get the power supply from the PDP 1105 and put his capacitors and straps back, and it should be identical. They're both the same part number, the same board etch revision E, see down there, 5009 777E. So yeah, just put this one together, test it properly without blowing it up, and put it in the PDP, in the PDP-8, while I wait for parts on this one. So that's what I'll do. There's a damn pity about this, and hopefully there's nothing more damaged further back, but we shall find out. 1973, so it lasted 48 years till I got my grubby little dick beaters on it. Okay, that's the supply from the PDP 1105 with all these capacitors put back in place. I also had to swap over the thermal switch because the one on this one was much too short for this box. That should be, I believe, across the 5-volt power supply, so no load, no variacs. We'll just turn on the power, see what happens. Look out for sparks. Now that one was higher than the other. The other one was what, 4.9 with no load. Alright, that's looking good for 5 volts. This one I think should be minus 15, yep. And plus 15 here. Well, that's good. Alright, and I'll stick the dummy load on that and see how it copes. Now, once bitten, twice shy, as well as taking the 5-volt load from 25 amps down to 13 with this business, I'll play it safe on the minus 15 instead of having 7 amps with this and that. Make it just under 5 amps with only one terminal connected. That's plugged into the plus 5 volts, so power on. Ooh. We had 5 and then we didn't. What's going on there? Check everything. Don't see anything wrong. Try that again. Although trying it again is what made problems before. No, 5 volts gone. Leave it on. Try the other voltages. Minus 15, that's still there. Good. Plus 15, gone. Bloody hell, we've blown another fuse. Bloody hell. Yeah. Let's see if it works without the dummy load again. If it's the fuse blown or if it's just having the dummy load on there. Bit of residual voltage there. That should be plus 5. Nope. There's a minus 15. Plus 5 is gone. Plus 15 is gone. Okay, well, that'll have to wait till tomorrow. I'm not going to dig into that tonight. Bugger. Yep, it's another blown fuse, this one here, which is the 15 amp one for the plus 15 volts and plus 5 volt supplies. Now that was with less than full load on that, full load on there, but that's only an amp. 13 amps on this versus a possible even 25. So if this thing's a bit piss weak or it can't start into the full load, maybe the load has to be applied after it's powered on. We'll find out when I get a new fuse. I've ordered them from DigiKey along with the new rectifier. I've got a fuse so I can afford to blow a couple, finding out how this thing works, but maybe I'll have to turn this on first then apply the load. But compared to the H777 supplies in the PDP 1104 and 34, where I could put the full load on all voltage outputs and start it up with that load sitting there, this thing seems to be a little bit timid compared to that, this H740. I'll find out a bit more once I've got new fuses. I'll see if I can turn it on, then connect the load and see if it still blows the fuse, or if it only blows it when you turn it on and the load's already attached. So that's going to be a few days before I can get around to that. Saga continues. So, resuming after a couple of weeks of procrastination, I've got new Pico fuses from DigiKey, 10 amp and 15 amp, and I got new rectifier to replace this guy, but I ordered the wrong sort with spade lugs instead of wire terminals. But I put that down to DigiKey because their images were wrong, and I complained to them and they accepted that and refunded me for 4 of these things, and then I bought the right ones and they paid for the shipping, so that was very good of them. 4 of the right ones. A few spares. I'll continue with this PDP 1105 supply for the moment, where the positive side's gone due to one or other of these fuses blown, so I'll replace that and gingerly apply power and the dummy load and measure stuff and see if it keeps blowing fuses. And out of paranoia, I just thought maybe I had this capacitor in backwards, but it sits across the 5-volt output, but no, that's not the case. So we're looking at the 5-volt output and let's turn it on. Right, here goes. That's not very good, is it? The 5 volts. That should be 5 volts. Plus 15 should be in the middle. That's no good either. What's going on? Okay, well, obviously our positive supplies have gone dead again. Minus 15, let's see how good that is. That's still okay. Looks like our pluses have gone again. There's some voltage there, maybe the fuse hasn't blown, but something's wrong. Okay, we'll turn it off. Well, the fuse isn't blown, so, and nothing felt hot, so looks like something is wrong inside of that supply. I won't worry about that for the moment. That came out of the PDP 1105. I'll put the capacitors back onto this one that I haven't repaired yet. Whoops, I better repair that burnt out trace. Put the new bridge rectifier in, put his capacitors back, and the 10 amp fuse on the, I think it's 10 amps, on the minus supply side. So there's a few things to do on that, and we'll try it in there and worry about this guy later. Yeah, so the minus supply on that one works, but not the plus 15 or the plus 5, plus 15. So it's unlikely that something's gone wrong with the internals of both of those. And there's the minus 15 which does work, so it's got to be something common with both of these, which is really only that fuse that I've just replaced, or the bridge rectifier on that one. Have I burnt out that bridge rectifier as well? Don't know. Anyway, I'm not going to worry about that right now. We'll turn our attention to this one, which is the original supply that came out of this computer. And on that, I've replaced the bridge rectifier. It's a bit thicker than the original. That bolt only just made it. Maybe that's because that's 50 amp and this is 35, I'm not sure. And I've put in some wire to replace that burnt out track and fortified all the other traces with solder. So now all I have to do is replace the 10 amp fuse for the minus 15, which was what was wrong on this one. Yeah, so I've just got to put back the big capacitors on this one and we can try it out. Right, on this one it was the minus supply that was failing, so we'll look at that one first. Turn on the power. Right, minus 15, that's good. And we should have plus 5 here. Yeah, and in the middle, plus 15. Very good. Now, do I dare put that dummy load on it again? I suppose I have to. Alright, we'll try that. With this connection not there, but just to these three, the plus 5 volts should only be drawing 13 amps instead of 20. The minus 15, with this disconnected, should be drawing just 5 amps, and the plus 15 is 1 amp. So that's all within the ratings of the thing, I believe. Once again, looking at the minus 15, and let's see if it blows up. No, -15 is holding up, +5, yeah, +5 there, and +15 is there, so very good. It's holding up under load. Just run it for a little while, boil some baby oil, just to be sure that it really is dissipating some power. But yeah, that's looking good. So I didn't run it for too long because, as it says here, the thing needs the airflow from the fan across there, and the heatsink was getting quite warm, so it was dissipating power. So I didn't run the dummy load test for too much longer. So now I've reinstalled it into the box. Now this internal box here that the power supply goes into did have some foam along the inside wall back there, as if it was to stop the power supply touching the other side, but I haven't replaced that with anything. That had all crumbled away. But it looks like there's nothing on the power supply that comes closer than about 3mm to the back cover anyway, so I don't think that foam is needed. And there's 6 points where the supply is screwed solidly onto the frame, so I don't think there's any problem with not having that foam there. So that's about it for now. I could turn it on, but this video has gone on way too long for just testing a couple of power supplies, and even one of them ended up not working. So turning it on and then trying it with cards, I'll do that in the next video. I hope you enjoyed this. Please give it a like, and I'll catch you later.